Good morning, students. And today we'll be looking at a library called SpaCy, and is a very nice library that you can use. I can imagine that you will be using SpaCy during pre-processing, right, or maybe analysis, right, to help you on your research papers, right? So I think having SpaCy on your toolset is a very useful, right? Another library is probably NLTK, but I guess SpaCy has a lot of nice functionality. Yep. And so before you actually begin, make sure you have SpaCy, and make sure you have downloaded the small and the medium and also the transformer. You don't really need the transformer, because in my tutorial I did not really use the transformer version, but the medium and the small contains a lot of nice word vectors and also similarity functionalities inside here. All right. And today so there will be like 2-3 parts of SpaCy in my tutorial. The first part is basically very fundamental, gonna bring you like basics things about SpaCy and also entity rulers and etc. Right, and then the second probably gonna give you some like simple tutorial on sentiment analysis and how you're gonna use SpaCy to help that. Right. All right. Without further ado, why not we start on the basics, right? But before anything else, let me just import SpaCy, and then I can print the version that I'm using. All right, so the mine is 3.5.1. all right, and let us first try the basics. So before anything, what we need to do is we want to load some core, some model, right, that is trained by the SpaCy guys, and we're going to call this NLP, right? And in this NLP we can do a lot of stuff, right? You can change this to either MD, which stands for medium, and also TRF, which stands for transformer. Yep. All right, so then we can try something like this. Text is equal to Chucky is currently teaching NLP on YouTube, right? And then what you can do is just say doc equal to NLP text. And in this doc, of course, we can firstly check the type, and it's spacy.tokens.doc, right? And so there's a lot of special things about this object, right? Firstly, you can extract tokens, so you can say for tokens and doc, and we're gonna say print tokens, token, right? And you can see that this doc object can be actually iterated, right, to get all the tokens, right? So they are very nicely splitted. Of course, you can try to play around and see, like put a apostrophe, exclamation mark, and see how does it work, right? Of course, Chucky is currently teaching NLP on YouTube. I'm not sure, like you can put an apostrophe channels, and okay, and escape this maybe, and we can see that okay, apostrophe S is actually a separate token treated by SpaCy. So SpaCy is actually very nice. Yep. And of course, if we print the only token, that is the exclamation mark, right? But of course, another thing you can do here is that you can also split by sentences, right? So here I'm gonna just say hopefully the students can gain some knowledge, right? And so my sentence is 2, now. And so what I can do is I can also split by sentences. So for send and doc.sense, print send. Right. So they also SpaCy also has a way to determine different sentence, right? So you can imagine that this is a very useful, right? And what are other things I want to talk about, right? Of course, currently the token is a full stop, and you can do something like this end type, right? And you can say 0, but if you try to take a look at what is this actually, you can put an underscore here, and it would say it's nothing, right? So what we can do is maybe we can end with knowledge here, right? And now the token is knowledge, and I'm gonna run this again, and we can now okay, so the end type is still missing, so it means that it does not really know the entity type of this, right? Or let us just prepend this, I mean end this with Thailand, and probably there's some token. Okay, great. So you can see that entity type is 384, and we want to take a look what is this. So this is a GPE, right? If I'm not wrong, GPE stands for geopolitical entity. All right, great. So you can see that SpaCy has a very nice abstraction of token, sentence, and also entity type, right? And of course, you can do something like this, right? SpaCy.explain GPE, right? And it can say something about this type. Of course, you can also do something like this. You can say token dot ent IOE, right? And recall that in another task which we learned like in the lecture, I think in the 5th video, so we got this BI, right? B just stand for it's the beginning of the entity, right? All right, and of course you can also do token.pos, right? And that is a proper noun. What else you can do? What is basic? Token dot dependency, and you can see that I guess this is a noun, phrase, adverb, modifier. I'm not sure what is that, but clearly there's some kind of dependency that is also demonstrated by the tokens. And of course, you can also try to take a look at the head. So you can see the gain is actually depending on this word Thailand, right? If you're not familiar with dependency, passing is fine, but you can see that SpaCy is also having that functionality. All right, and of course, if you want to take a look at this dependency, we can always do that, right? So we can say from SpaCy import this SpaCy, and then SpaCy dot render sentence 1 style depth, right? And I want to get the sentence 1, so just give me 1 second, right? So I'm gonna say sentence 1 equal to list of doc.sense, and I want to take the first sentence. So the first sentence is simply this one, and once we take a look, we can see that we can get a very nice dependency passing trees, right? So teaching is depending on Chucky, and in the relationship in which Chucky is actually the subject that actually teach, right? Currently is an adverb that modify teaching, right? For example, right? So this is a very nice dependency passer. So SpaCy has a very nice dependency passer, right? Of course, you can also use the style like ENT, and you can get a very nice color like this. Like Chucky is an organization and is currently teaching NLP organization. I don't think this is true, right? NLP is probably a subject and Chucky is a name. So you can see that SpaCy may not aware of this new word, right? In those cases, you want to train your own name entity recognition on top of SpaCy. So SpaCy also allowed you to train on top, right? But anyway, today we're just gonna introduce the basic things we can do with SpaCy. All right. So I think that's a very quick review of the introduction. The next thing is word vectors. So we have studied a lot of word vectors, and the word vectors is only available when you actually use the medium model. So I'm gonna just load the medium model, right? And remember that we have learned word2vec, Glove, right? Of course, we haven't studied fast text, but fast text is basically a character-based word2vec, right? And of course, currently everyone is using bird, right, as an embedding, right? Like sentence bird, for example. But anyway, SpaCy provide a lot of classic embeddings that is still very useful until today. So you can do text is equal to Chucky likes to eat sushi, right? And okay, I forgot that. And then you can again put it into encapsulate that into a doc, and then we can get the sentence equal to list of doc.sentence 0. All right, so that is our sentence. And then what we can do is of course we can now get 0, and that is Chucky, right? That is the first word of the Chucky. And then we can also do something like here, that is a sentence 0 dot vector. And what we're going to do is take a length, and you can see that actually the length of vectors is 300. So what does this mean? This is a trained by Glove as a 300 dimension of embedding, right? So each of the word has a dedicated vector that represent Chucky. I guess this 301 is represent unknown, right? Because Chucky is an unknown word. But anyway, you can see that SpaCy also provide this vector that you can actually work with. All right. The next thing we're going to do is because we have this vector thing, it's very clearly that we can also do some similarity functions. So we can try doc equal to NLP. I love coffee. All right. And so we have that. And now what we can do is we can get the hash value of this coffee number, this coffee object. And then we can perform some similarity checking. So we can do NLP.vocab .strings coffee. And we got this hash value, which actually represent coffee. And we can also, of course, map it back to .vocab .strings. And we're going to copy this. Right. And you can see that this has a very unique ID for each of the word. Now, what we can do is we can get the string of a dog. Similarly, all right, and then what we can do is, of course, you can now get the vector. NLP.vocab.vectors and input this integer, And of course, this vector, the length of this vector is 300. So you can obviously take a look at the first, I would say first 5, and you can see that the numbers look like this, right? So basically, same thing as what we have learned in the embedding classes. And then what we can do is we can do something like this. We can do import numpy as np. Sorry. And we can do nlp.vocab dot vectors dot most similar to np dot as array vector, right? And we want any vectors that is most similar to this vector, right? And then n equal to 10, and we're gonna set this to something called close words. And now we're going to print this out, and you can see that there's a lot of integer, right, that you can actually try, right? So what we can actually, so I think the first array is what we want, right? I don't remember what is, I guess this is the similarity score, and this is probably some numericalization and numerical ID of those words, right? So what we want is the first array, and 0 is basically taking out this bracket, and 0 is this exactly this ID, right? So we can do np dot nlp dot vocab dot strings and take in this number and see what is actually, and it's called doc's body, right? So this is doc and doc's body. I'm not sure what is that, but let us change to 1, and we got roof dogs. We got, I'm not sure what is that, but probably a type dog and duppy, right, etc. Right. So you can see that SpaCy actually provide very useful functionality for your costs. Yeah, of course you can. So that is the similarities, and of course you can do some document and span similarities, right? So we can try. By the way, for the similarities, since you have the vector itself, you can do your cosine similarities for yourself too, right? For the doc and span similarities, we can do something like this, right? Doc1 equal to, sorry. Chucky likes French fries. And then doc2 is NLP, Chucky, Tom likes some sweet potatoes and nuggets. All right, and so what we can do something like this, right? Doc1 dot similarity doc2. All right, and that is 0.62. We can try something like I play football yesterday, right? And then we can try, sorry, doc1 with doc3, and you can see the similarities is lower, right? I'm not sure what is the inner algorithm of SpaCy, but you can certainly take a look, right? But I'm very sure that SpaCy did not use something like sentence bird, right? Which is something you should also take a look, right? Of course, you can also do span, right? So span 1 equal to maybe doc1 2 to 4, and span 1 is simply French fries, and then span 2 is maybe doc2. I'm not sure, like 3 to 5. What is that? I'm not sure. And that is potatoes. And we can do span 1 dot similarity with span 2, right? And that is 0.5, right? So please play around, and you can see that you can also do document sentence similarity, span similarity, basically phrases similarity, and also word similarities, right? Which will be very useful for your analysis, right, in your research papers. All right. So those the introduction, and in the next video we can work on entity rules. Right. See you in the next video.